Hey guys, so this was part of the chapters that we were sort of unable to finish during class time. So I do have worked examples up for this on our eLearn, but as we know, the situation with the eLearn was a little bit tragic yesterday. So I'm going to film a couple of videos on this complex number stuff as part of the review. But if you want me to go back and film stuff from previous chapters that we've covered in class, or you've got a specific question from, like, let's say chapter 3, just email me and let me know and I can go through it and work through that with you. All right, so complex numbers, let's just do a quick review of what a complex number actually is. So a complex number is just a number that has a real component and an imaginary component. So an imaginary number, this number I, is equal to the square root of -1, or alternatively we can write this as I squared is equal to -1. So what I'm going to do, right, is I'm going to factor out this -1 from these terms here, and then I'm going to be able to determine what the expression is for each of these. So using our surd law for this first one, we've got the square root of -25. That's the same as saying the square root of -1 times by the square root of 25. Square root of 25 is 5, and the square root of -1 is I. So we would write the answer to this one as 5i. So the rest of these actually become pretty simple then, because effectively we're just doing the same process again and again. So this second one, we're factorizing out the -1. So root -1 multiplied by root 144 is going to be equal to 12i. All right, same thing now with the fraction. We're going to factor out -1. So square root of -1 times by the square root of 4 over 25. This is a nice square fraction, so that'll make it nice and easy for me. So this is going to be 2/5, and then the square root of -1 is I. All right, let's do this last one here, D. Now with this one, the 23 is a prime number, so I'm just going to leave this as the square root of 23i. Just to explain why I've done that, because what I've done is I just factorized out that -1. Okay, so express each of the following in the form a plus bi. So this is the complex number form, where a and b are real numbers. I think they meant to say integers or something there, because obviously this is not going to be a real number if it's attached to I. All right, so I'm just going to erase all that and come back. Okay, let's have a look at this particular question here. So we know that I squared is the same as -1. So effectively all I'm going to do is I'm just going to change all of these i's with powers into some sort of number. So I squared we know is -1. I to the power of 3 is the same as saying I squared times by I, and so therefore I could write this as -1 times by I. So when I go to rewrite this particular expression, I'm going to rewrite this as -I plus -1. But because I want this expressed in the form a plus bi, I want the real component first, and then I want the imaginary component second. I'm just going to flip these two around. So, and I'm also just going to condense this little bit here. So I'm going to have -1 minus I. So that's now in the complex number form. All right, let's do the same thing for question 2. Now again, we've got these crazy powers here. Now a nice little thing, if I have I squared is equal to -1, right? If I have I to the power of 4, that's like saying -1 squared, which is the same as 1. So every time this is raised to some fourth power, I know that this value is just going to be equal to 1. So this is just going to be 2 times by 1, so that's nice and easy. And then this one here, we're going to have I to the power of 12 is going to be 1, so we're going to be left with I to the power of 3. And I to the power of 3, as we already know, is going to be equal to -I. So I can just replace this with -3i. Okay, question C. I might write this one down. So we've got 2i to the power of 5 minus 3i to the power of 6 plus 4i to the power of 7. So again, all I'm going to do is I'm going to factor out I to the power of 4, because I to the power of 4 is just 1, and I'm going to be left with 2i minus 3i squared plus 4i3. And then I'm just going to condense those again because, well, this one can't be condensed any further, but we know that I squared is equal to -1. So -3 times -1 is going to make +3. And then I to the power of 3 is the same as saying -I. And so we can write this as -4i. Then I'm going to collect my like terms. So 2i minus 4i, this is going to become 3 minus 2i. All right, I might just quickly erase this top bit and then I'll just show you this last sort of worked example here. So we've got I multiplied by I to the power of 4 plus I to the power of 5. So we can simplify within the brackets first and then expand, or we can expand then simplify, up to you. I already know I to the power of 4 is going to be 1. So this is going to be I 1 plus, let's factor out that I to the power of 4 and we'll get just I left over. So this is going to become I plus I squared, and we know I squared is -1, so this is going to be -1 plus I for the last one. Okay, so let's move on. I'm going to clear this again and I'll go through question 3 with you. Question 3 is actually a worked example in your textbook. So if you go to this chapter 5.2 and look at that worked example, you should be able to work this out. So I'm just going to do probably 3a and 3c. So when we're dealing with complex numbers, like I said before, we've got the real part and we've got the imaginary part. And so sometimes, we'll have z is equal to the real part plus the imaginary part, because z is just a number that's going to represent a complex number in this particular case. And so rather than writing this like in this form, I could write this as the real part of z. So in other words, if I've got this complex number z, the real part, so I'm referring to this value a here, and then the imaginary part of z is going to be equal to this bit here, okay? And so what I'm going to do, when this is saying evaluate each of the following, it's really asking, okay, so what's the real part of this expression? So the real part of 8 minus 9i is just going to be equal to 8. Same thing here, if I wanted to do the imaginary part of 17 take away I, the imaginary part is just going to be -i or -1. Okay, so question 4, draw an Argand diagram. So an Argand diagram is just the same thing as a Cartesian plane, except on the y-axis we have the imaginary axis instead of having a second real axis. So again, I'm just going to clear this and I'll come back. Okay, so this question here, so draw an Argand diagram. So let's just quickly, oh, actually I can do that using this tool here. That's nice. And let me draw my axis. Now, your textbook does this a little bit differently, so you might see some different notations for this. So typically what you would write on these axes is you would write the x and the y axis, except this time we're going to write the real component and we're going to write the imaginary component here. The other way that I've seen it written is that this is using the lowercase x and this is using uppercase y, and they use uppercase y to represent the imaginary axis of y. So you could see either of these sort of options when dealing with an Argand diagram. All right, so first thing it wants us to do, it wants us to mark on the complex numbers u is equal to 2 plus I. Now, when we have a complex number that's in this form, effectively this becomes our x component and this becomes our y component. So for this is going to be 2 and the coefficient of this number is going to be 1. So I'm going to plot the point 2, 1. So if I just pretend that that's 2, we'll just pretend that that's 1, and I'm just going to, and that's it. That's all we need to do. And also I should probably label that with u. Okay, the next one is 1 plus 2i. So again, this is the real part. So it's my x-axis. This is the imaginary part. So that's going to be my y-axis. And so this one I'm going to plot at 1, 2. So that one's going to be 1, and then that one there is going to be 2. And so that's going to be my point there. And they use the letter V to represent that point. All right, the last one, w is equal to -2i. Now, there's no real component to this, so therefore the value of the real component must be 0. So I'm going to write this as 0, -2. So for this one, we're going to need to extend this y-axis a little bit. So this is going to be that particular point there, so we're going to write that as w. And there we go. Now, with this one, on the same diagram, mark the following points. I'll just show you IU. I'm not going to go through and do all of them. I might pick a different color. So IU is the same as saying I times by U, so 2 plus I. So expanding this out, I'm going to get 2I. plus I squared, and we know I squared is equivalent to -1, so we're going to rewrite this real component first. So -1 plus 2i. So that means the point IU is going to be plotted at -1 and 2. So I'm just going to go ahead to pop this here, -1 and 2, and so this is going to be my point for IU. Okay, so it's actually being translated or rotated around by 90 degrees. And the same thing will happen for IV and IW. Okay, last one, question 5, draw an Argand diagram and mark on it the complex numbers, blah, 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 blah. They've actually just done this question, haven't they? I don't think I'm going to redo this. So those are just some simple questions for complex numbers. So just a review of the basics. So if you want, we can go through some trickier stuff. What other questions do we have? I don't think this is a particularly tricky thing. Maybe I'll do some multiplication questions next, some algebra stuff. All right, so if you are interested in looking at some algebra of complex numbers, then I will show that to you guys in the next video. All right, hopefully see you soon. Bye guys.